happy to chair this session. So the title is Investment Behavior and Energy Efficiency. In practice, there is a lot of variety, I would say, because we're going to hear about vehicle purchases and then about energy efficiency in general. And then we will have a presentation on the finance and this type of investment. So we will start with the paper Consumer Myopia in Vehicle Purchases, Evidence from a Natural Experiment, and presenter is going to be Sebastien Houde. So you have in total 35 minutes. So in case there are no interruptions, I will stop you after 25 and let you know during the presentation how the time goes. And it is like a meeting, so anybody who wants to ask questions during the presentation is welcome. So Sebastien, the floor is yours.
Perfect. I just want to apologize in advance. In about 15 minutes, I will have to transition my kids out of the house, so I might be interrupted for a couple of seconds in about 15 minutes. Okay, so thank you very much. Very happy to present this project. This is a project coming to the end of its life in terms of from our side, from Kenneth, Arthur, and me. It's a project we started a long time ago, but we are, I think, presenting one last time this paper. Okay, so this is about a question. Well, the motivation of this question is we are using standards to regulate vehicle emissions. Or I would say not only emissions, but energy consumption from vehicles. And the underlying motivation of using standard versus taxes, another instrument, or just information, is that back in the days, in the 80s, when we started designing a policy for energy efficiency, managing energy demand, there was this belief that consumers underestimate fuel costs, okay? So standard, no, sorry, I'm presenting, I will wake up. I'm presenting my slides in the reverse order. The motivation is we need to study fuel economy standard. This is a very important policy. But the reason that we are living today with fuel economy standard is, and if you see my slides here, and I will increase, is that there is this belief that the consumer valuation of fuel operating costs is such that there is some sort of bias. Consumers, on average, underestimate fuel operating costs. And that has been a very controversial topic for the last 40 years. So this is how the fuel economy standard came about, partly, is the fact that we think that consumers, when they purchase a car, appliances, even a house, they don't think about the energy operating costs. So there's a regulation here to force manufacturers to offer fuel efficient vehicle. Okay, so this parameter, there's zillion of papers that have looked at estimated that parameter. We are doing that again. So why we are doing this? And let me just make a small detour. But okay, the debate, sorry, to just be clear, is that there is kind of a belief that there is a misoptimization. So there's a bias, a systematic bias when consumers think about fuel operating costs, and they don't trade off $1 in fuel operating costs the same way that they trade off $1 in capital costs. And in particular, the belief is that they undervalue, so they tend to dismiss a little bit the fuel operating costs of a vehicle. And that, of course, is a problem, because it means that if manufacturers offer, fuel efficient cars, consumers will not fully realize the benefits of those cars, and the rate of adoption economy-wide will be too low. Okay.
So this is really very different from what we heard during the Yellow Vest protest, because they're saying, our fuel costs are going to be too high. So I mean, how do you tackle the natural experiment as well in some way?
Exactly, and the Yellow Vest was interesting, and without being an expert of the movement, what I heard is that people were evaluating fuel costs. So it was much higher. No, I think it had to do with the tax, and I think the calculation that people were doing it was an exaggeration. They were like, oh, it would be so expensive. Now we have a bit here in Switzerland. There's this vote on the CO2 law, and we hear a lot of that also, that the costs will be very high and so on. So it seems that there are moments that maybe there is an overvaluation. But in general, over the last 40 years, when researchers took a lot of data, and here this is a bit of a summary of the debate from the recent, I would say from the most recent evidence. Here, okay, the way to summarize this behavioral parameter is there's two parameters. They are isomorphic. They map one into the other. So in this paper, we'll use the valuation ratio. The valuation ratio is what? Is how consumer trade off $1 in discounted fuel operating costs versus $1 in capital costs. If the valuation ratio is 1, this is, I would say, the rational benchmark. Okay, this is there's no problem. This is $1 here, $1 there, all is good. And what you see from the recent evidence, that there is not that much evidence, if you look at those 4 first papers, that there is a systematic undervaluation. If you look at the paper from the 90s, 80s, or early 2000, that was different. You tend to find a valuation ratio well below 1. What has changed here is that, first of all those papers are using quasi-experimental variation. And mostly, the 2 important papers that were really influential in the debate, the first 2, they are using variation in gas prices. So not variation in tax rate, not variation in other things. This is variation in gas prices. Salé et al., this is a bit of variation in gas prices, but they use a different natural experiment. And Grigolon et al., this is a variation, and Laird et al., Laird, Lin, and Zhu, I believe. They use variation in the technology of the car. So they have an IV strategy to do this. And then they find a valuation ratio that is much lower. Okay, so this is a bit where we are today. Without this paper, people have been saying the last couple of years that forget about this undervaluation. There is no undervaluation. All is good on average. What we are doing, sorry. Okay. We will go back, estimate the valuation ratio, and then we have a different source of variation, because all that variation is, technology adoption, gas prices. Our view is that if fuel economy standards are changing, what consumers will see, this is a change in the information that they see when they go at the car dealership. And the context here is in the US, but you should know that in the US, a bit like in Europe, you have those nice, labels, pretty complex, with a lot of information about fuel economy. And if our view is that if the regulation change, what will change? How consumers will learn about a change in fuel economy standard? Well, they will not study the technology and so on. This is what Laird and Lin and Zhu are arguing. What they will see is different pieces of information at the time of making a purchase. So for us, the ideal source of variation would be if we could change that information. Unfortunately, this is not possible because by law, those labels have to be like that. And many, many researchers have tried to convince the EPA, the DOE, or the US government to change those labels to try to learn what are their impact on behaviors. Not possible. But here we have a nice natural experiment. In 2012, there are a couple of manufacturers, 2, that reported the wrong fuel economy number. And the EPA say, hey, wait a minute, you made a mistake in computing your fuel economy number, and you have to revise them. So then what we see is the same brands, the same model within brands with different fuel economy label. And we are using that variation to say, okay, given that we have the same cars, same characteristic, but just the label has changed, what would be the impact on the market? Long story short, we'll find quite a bit of undervaluation. The way we rationalize this relative to the previous literature, they say, hey, wait a minute, this is a different source of variation. It's not gas prices. It's not like the yellow vest CO2 tax or some sort of tax. This is information that people see at the time of making a purchase. And that has not a strong behavioral effect. Okay, so that is pretty important from our point of view, from a policy point of view. Okay, so we'll do different things, but we'll look at we'll run basically 3 regressions. The first is this is a hedonic regression. So we'll have a transaction price of a vehicle in the US. We'll have the change in label, and we just looking at this event. Does it impact prices? And the answer is yes, a little bit. We see on average, this is a robust finding of a decrease of 1.2% in prices if the fuel efficiency is decreasing. Okay. We look at the impact on sales. I will explain a bit later why it's important, but we don't find any impact on sales. And then we are using those 2 regressions together, and we can back out our consumers with some assumptions, of course. Our consumers value the willingness to pay for discounted fuel costs, and we are finding a valuation ratio of 15 to 38 cents for a $1 change in capital costs. Okay.
Why did you choose discounting at 4%? I mean,
this is a big debate
because it's different from the other studies.
We'll have so in terms of producing that number, we did from 1% to 12%. This is a big debate when you do that type of exercise, which discount rate you are using. Our discount rate doesn't change qualitatively the conclusion that there is substantial undervaluation. The discount rate we are using is using exactly the same approach of the other papers. Okay, so this is just adjusted to fit our sample period. So we are apple and apple in terms of choosing the right discount rate in terms of the previous literature. I should say that this paper is has a bit of a flavor of a replication exercise, although we are not replicating any finding of others. But we went in great length of, okay, this is what the other papers have done, and we have just take the same assumption, recomputed our number just to be sure that the underlying assumption to come up with this 15 to 38 cents for $1 in capital cost is not driven by different assumptions. So that we were pretty rigorous and pretty complete to do this. Just a parenthesis, in my view, the discount rate, there's a lot of attention in the literature on that parameter. This is not what is driving the big difference. There are other things that we haven't really put enough emphasis that are much more important than this discount rate. Okay, this is if you were to buy a car in the US. Now I think that's already changed, but at the time during our sample period, this is what you will see. And like I said, this is a very detailed label. The number that we care about is this 26 mpg. This is miles per gallon. They do things differently in the US. They do things in mile, and the ratio is inverted if you are living, let's say, in Canada or in Europe, that we are looking at a gallon per, not gallon, it will be liter per kilometer. Okay, but that number, when this number is going up, this is good. When this number is going down, this is bad. Okay, and so what happened is the manufacturers Kia and Hyundai, when they, for a subset of models, they had overestimated that number. So our natural experiment is we have a subset of models that this number will go down, and this is pretty sudden. From one week to the other, the label had to change. Okay, so this is the nature of the natural experiment. EPA once in a while they do an audit, and they found that a couple of models of Hyundai and Kia were overstating their fuel economy values. Automaker said, okay, not our fault. It was a good faith engineering error, blah, blah, blah. And then we had a lot of vehicles that were, in the dealership that were already produced, manufactured, that had to change their fuel economy label. Okay, so that is really important because it's not something that was announced. It's not something that manufacturers had, could anticipated. It was really a shock It was, I think, on November 12, November 11, 2012. The number changed. The EPA did a press release, and 1 week later, that changed. The change is not.
Any idea on the amount it corresponds to for the lifetime of the car? If you take a car that is consuming average for 1 year, you keep the car, I don't know, 10 years.
So the change, you know, this number, okay, changed by 1.5 on average. Okay, this is pretty. Looks pretty. Is it small or big? This is your question.
Yeah.
This is okay. This is about $1,000, roughly. Depends of the model, but about $1,000 over the lifetime of a car.
Okay.
So is it okay? Now, if you compare also to the other literature that use variation in gas prices, the source of variation, the size of the variation that it induced between cars, this is a bit similar to what variation in gas prices is doing, and other people have used in their study. A bit smaller, but we are not an order of magnitude smaller either. Okay, so we are in the same ballpark. Okay, just an example, but there's a number for city, highway, but this is what you observe. Sometimes was bigger, 4, sometimes 1, and so on. Okay, consumers didn't see that. This is us. This is the New York Times, I believe, that produced that number. No, sorry, the Associated Press. Okay, once again, I don't want to hammer that too much, but it was like a last minute unexpected shock, and for us, this is a good thing to exploit that as our source of variation. And again, what is important is this is variation within brand. So this is not all models from Hyundai and Kia that were affected. This is a subset of those models. Okay, so this is very nice that we have a subset of models, because now you can imagine what happened with Volkswagen a couple of years later. You know, back in the day, in 2012, this restatement was a big deal. It was the biggest lie that manufacturers had done. Now we have been a bit overshadowed with the Volkswagen scandal. But if you think about the Volkswagen scandal, there was not only an impact on cars that were affected by this, but also on the overall brand. And that also is a concern for us. What is the impact of this change on the overall brand of Hyundai and Kia? So this is really important that we are able to control for that, or rule that out, that what we are finding is not just a brand effect, but really an effect on the label that was restated. And what is nice is we have nice variation within brand from models that were restated versus models that were not restated. Okay, so this is it's kind of an ideal setting. Okay, for those of you that have worked with the vehicle data, you have two sort of prices. You have the price that is announced, and in the US, there's a big difference between what manufacturers state or suggest as a retail price, so the manufacturer suggested retail price, and the price that is actually paid by consumers, because there's a lot of variation going on and negotiation going on, and the transaction price tends to be much lower, and also heterogeneous across regions and so on. So we are using transaction price. We have nice data that has that, and we are bringing different sources of data to make it work. Okay, just quickly, this is summary statistic. I don't want to spend too much time, but a lot of model. This is 1 million of Hyundai affected model and 500,000 of Kia. So there is volume there. This is the price in 1,000 and so on. Just to show you that the price is a bit lower, so this tends to be a bit more cheaper cars than what you have in the market, but this is not drastically different. And here you have variation also across different type of car. And what we want to show here is that you have also all type of cars. You have the SUV, small sports car, so on and so forth. Okay, the majority for Hyundai was a small car, but still variation. Let me move on now. This is what we are doing. Okay, this is kind of our main regression. We'll regress price, transaction price on, and here this is the important thing. This is a dummy that turned to 1 after the restatement and turned to 1 for the affected model. So what we have here is really a diff and diff, and we have a set of control for the make is the brand, vehicle class. And what is really important here is this omega J. What is this omega J? This is a definition of a vehicle that we use in the US. This is called VIN-10. So this is really what you see at the car dealership. So we have a really fine fixed effect. So we really, if you haven't understood that yet, this is the same model with different information with a shock. Okay, so we are really controlling in a very, I would say, precise manner for all vehicle attributes. And then we have time fixed effect, other things, but this is really this fixed effect. And also this fixed effect, the brand interacted with time, that will make our diff and diff capture what we really want to capture. Okay, we can go in details, but this is a diff and diff, difference in differences, specification. And there's a lot of things that we need to show you that this is a valid identification. We do this in the paper for the sake of time, and because it's still early in the morning, I will not go into those details. But take my word for it. This is a good diff and diff, a valid diff and diff. At least we have been able to convince some referees. Okay, so this is what we see. The simple regression price on post-treatment for affected model. This is the change. This is in log. So this is a 1% to 1.2% change in transaction price. In dollar, it amounts to about $150 to $300. Okay. So now, is it a big or a small number? The little guys just left. Okay. Before doing this, let me just show you over time. This is an event study type of graph. This is the treatment effect over time. It's not super precise, okay, because we are going month by month, but you see that the restatement on average, it goes down. And so this, when you take this average, this is statistically significant. And this is a reduction of about 1%.
You have about 5 minutes left.
Five, you said 5?
Yes.
Perfect. Okay, so quickly, we look at the quantity effect. This is really important to estimate the quantity effect, to have a sense of what is the willingness to pay. This change in price, how do we translate that in willingness to pay that consumers have? If the supply is perfectly inelastic, the way to think about what we are doing is we have a demand pre-restatement for those models. What this restatement is doing, this is changing the information that consumers are seeing, and this is bad news. Okay, they are less fuel efficient than expected. So the way to think about it is this is a shift down of the demand curve. If supply were to be perfectly inelastic, the change in price that we observe will coincide perfectly with this lateral downward movement in the demand curve. And what is that? Well, that will be our willingness to pay. So if we are looking at a market where supply is perfectly inelastic, the change in price that I just shown you will be also a change in willingness to pay. That, of course, doesn't hold if the supply is not perfectly inelastic. Okay, so then the change in price will underestimate the change in the willingness to pay for fuel economy. So we have to say something about the supply. Now, without doing any regression, this is important to keep in mind that the shock was unexpected. So all the models were produced. Okay, they were out of the manufacturing, the supply chain. So they were on the dealer lot and they had to be sold. So to some extent, they were, they will not just destroy the car, they will sell them no matter what. Okay, and what they can do is change the price to be sure that they clear out the inventory. So the nature of the shock makes the supply pretty inelastic. okay, we look at imperfect competition, blah, 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 a lot of things that we can push when we think about the supply. But what we are finding basically is a very imprecise estimate of the effect on sales. If anything, it was positive. This is not statistically significant, very noisy. So we are not able to really pin down a number. So what we are doing in the paper, we are in the next step, okay, discussing why there's no sales effect. This is what I just discussed. What we are doing in the paper, the last step is taking our difference in price and translating that in change in willingness to pay. And we'll do that under different assumptions regarding the supply response. We are starting with perfectly inelastic. Given that we don't find much on the quantity effect, we are saying, okay, let's take that as our main estimate. But then we have done a lot of robustness check with a supply that goes in all directions, even a downward sloping supply, just to be sure that we are pretty complete and just to show that our willingness to pay is robust and our conclusions is not influenced by what we assume in terms of supply elasticity. So quickly, we run another regression to do the willingness to pay. The only things that change is we are constructing a variable that is the variation in discounted fuel operating costs. That regression looks pretty similar. This is very similar. If you look at the Stata code, the only difference is that the identification strategy needs to make more assumptions. And so we go in the paper discussing what are those assumptions and defending those. But what is important here is that we obtain from that regression a parameter that this is the valuation ratio. So if that number was were to be one, that would be, okay, there is no undervaluation. The fact that we see something, let's take the value absolute, the absolute value of that, below 1 means that we have undervaluation. Okay, I'm running out of time, but why 2012 versus 2013 model? We are looking at this heterogeneity because the 2012 model, the restatement was in 2012, at the end of 2012. We think that the supply there was very inelastic. The models, for sure, they were all produced. They were all in the dealership or on the dealer lot, ready to be sold. In 2013, manufacturers had a little bit more margin to change the manufacturing decision, and maybe they decided to produce a bit less. So the supply is this is less likely that the supply is perfectly inelastic. And what we are finding here is consistent with that. This number is underestimating the willingness to pay, most likely. This number is most likely to be consistent with change in price equal change in willingness to pay. Okay, so many things after that. We go take our estimate. We went back to the literature. We try to explain why this is different. We vary the discount rate. This is what others have found. And we are finding basically that our main finding that we see a lot of undervaluation is robust to the way we do things, to the underlying assumptions. And so basically our number is not putting an end to the debate, but saying, wait a minute, the consensus that there is perfect valuation is maybe not so true. And the point that we are making here, we are the first of using that variation, which is in the fuel economy rating. And that, from a behavioral perspective, this is very different than change in gas prices. This is also very different with what happened in France with the change in taxes. So, our conclusion is, if you were to do a policy analysis and you need a parameter of how consumers value fuel operating costs, you should use the variation that match with your policy that you have in place. So don't use variation in gas prices to study fuel economy standard, because this is different things. Use that to study maybe a gas tax, and then we can argue that even change in gas tax versus gas prices can be different. But this is change in information, and that is very different than gas tax or gas prices. Okay, thank you very much. Hopefully the coffee may work for you.
Yeah, so we have a little bit less than 10 minutes for discussion, but that's already something. So
It would be nice if you can open your camera when you ask questions. Yes, perfect.
Can I ask a question?
Sure.
Okay. Well, thank you very much. I really enjoyed it. But just curiosity. Is there any possibility that the data has a time series feature, like present data can be affected by the past data or something? So AR auto regulation model style or something. So is there any possibility? I'm not sure, but about the feature of the data.
Yes. We have, let's say, our main regression, which has a transaction price. So there is a, there's a serial correlation that is definitely possible. So I think for us, this is more from a standard error point of view. What do we do there? So we are trying to be as flexible as possible to cluster our standard errors to account for serial correlation. This is kind of with diff and diff, this is the problem. If there is serial correlation, you need to be careful in what you do with your standard errors. And we are using I would say the best practice in terms of clustering to be sure that we are not underestimating our standard errors and not having a false sense of precision.
Thank you.
Thank you very much. Any other question from the floor? Do not hesitate to just open your camera and ask the question, or even directly ask the question if opening the camera is an issue.
I can just, there is no question. There is one thing that we discovered that was pretty interesting in this this paper. That is, it's coming at the end, but the technique there are different ways to back up the valuation ratio, and we are doing it through a regression here. So we are computing kind of the fuel operating cost there, and we are estimating the valuation ratio right away. Some people have computed the average change in price. Another regression, they compute the average change in regression, and they use those two average to back out an average valuation ratio. And what we are showing in this paper is that if you use those two average to compute an average valuation ratio, this is an approximation of the valuation parameter. And for us, that has a pretty big impact. And if you use this approximation, it basically double our estimate. Okay, so this is our estimate for different discount rate. Let's say take the 6%, 18 to 0.44. If we use the approximation, we double this. And some of those papers, they use this approximation. So without saying that this is because they are using this approximation, for us, that's, just in terms of technique, it's not an assumption. It's just, because you are using the ratio of two average and you are missing out some useful correlation, you might be vastly overestimating. In our case, this is a factor of 2. So, maybe this number is half of that if you use the exact valuation parameter. Anyway, I had a bit more time left, and for me at least, it's a pretty interesting point, and that for me that is also this paper would be worth to redo same data, different estimation technique to see if that will be survive the method to back out the valuation parameter.
Yeah, that was my question. So it's possible to do. I mean, the data are available. That would have been interesting to actually do.
Yeah. This is the problem with the car literature that recent. Having those data is really hard. And even though this is the ER, this one, this is the ER paper, of the data are not available. This is transaction level data that they got through an old agreement, and now they are not giving that data anymore. We try.
Okay. I had a couple of questions, but maybe we can ask again once more if there are some questions from the floor. We still have a couple of minutes. So in case we don't, I would like to come back first to your policy implication. You were, stressing at the end of the presentation. So that was really, I think you were stressing the fact that your results really do apply to standards, right? So we can interpret that, and it says we have to be careful when we implement policies regarding to these fuel standards for cars. But anything we could use for any other type of policy, because it's very specific policy. So in particular, when you think about a carbon tax, is there anything we can exploit from your study to say something?
I think among the three co-authors on this paper, we quibble a bit after that about that. But my view is we need to be a bit more humble about how this is a very controversial numbers and really discuss it pretty heatedly. And I don't want to comment on the referee process, but just what I've seen from the inside the conversation, people are willing to take that number and apply to, this is the number to think about undervaluation. And for me, this is like a elasticity of labor supply. If you want to study labor policy, you cannot take the labor supply of a woman over 50 to study policy of a young couple between 25 and 35. This is a bit what we have here. And this is a bit disappointing that I'm telling you that you will need to run different studies to study different type of policy. But I'm a pretty big fan of this approach. I will not be in favor to use that number to study a gas tax or a policy that is more price-based, because I think from a behavioral point of view, this is just a different animal. Consumers see different things, they have a different emotional response. And I think we need to think out of the rational realm, and change in information is really different if this is impacting a number or a label, then this is impacting the price that you see at the pump where you drive every day. So that's I stick to that different policy, different source of variation. We need different studies.
Okay, that's quite convincing. One last question before I go for the next speaker. You were speaking about also, data, and particular or relatively old data used by previous papers on the price of car. What do you think about web scraping right now that is currently used in some papers to try to get the price of cars? So just using the website, did you use it? Do you think it's, do you have any opinion on that?
I like this. It depends of the context. In the US, what is very strange is the price is this is a negotiated price. So if you go buy a car, the dealership, you will look at the car, say I'm ready to buy, and then you enter a negotiation process, and then then there's a person hiding in the office. And the seller will talk to you, will go back and forth with offers. This is really a bargaining process. So web scraping for cars in the US won't solve this problem. Mm-hmm. But in other countries where this negotiation is not happening, yes, of course. So anything that is closer to the final price paid is very good. And yes, I'm a big fan of that, when this is possible, when this is legal. And sometimes just for, just cross-country comparison can be also interesting to see the same cars with similar attributes across countries and see how things are varying. So we should take advantage of that. I think this is a very nice source of data. But it doesn't solve, in some context, the US context cars, it doesn't solve the problem. Appliance, yes, it solves the problem. There's no negotiation going on. So.
Mm-hmm. Okay, thank you very much. So where can we expect this paper to be published in? Because you made the...
Yeah, this is forthcoming in a couple of months in the American Economic Journal, Economic Policy.
Okay, great. Congratulations.
Thank you.
So let's go for next paper then. Okay, so I think we already, Akira Maeda, we already checked that we could share the screen, so everything should be smooth.
Okay.
We're going to hear is identifying obstacles to autonomous energy efficiency improvement.
Yes.
So again, I mean, all in all, you have 35 minutes to do your presentation.
Okay, thank you very much. Again, my name is Akira Maeda. I'm talking from Tokyo, which is 2 p.m. afternoon, and I'm really happy with this arrangement because some of you are in the late morning, right? So I'm kind of energetic. But anyway, my talk on is about identifying obstacles to autonomous energy efficiency improvement. And notice the last one, a previous version of this study has been presented at another energy conference 2 years ago. Well, so motivation. Let me start with motivation, and maybe my study is on the same line with the Sebastian, and we can share. We share the same motivations, I think, but mine is completely different in the sense that it has no dependent on the data. So I'm not reading the data. My analysis is purely theoretical, and my model is very simplified one. It may look like something less cutting edge, but I think the simplicity can be helpful for the insight for policy debates, I think. So again, motivations, good technologies end up with widespread use. So that's the starting point of my question. So standard economic theory says exogenous technological change or progress or improvement is formulated as a function called the production function, and A here, which is called slow residual, simply represents the technological change, and it is assumed to follow an autonomous increase. And then after that, endogenous economic growth theory comes in. And the slow residual A is assumed to be a function of capital input K. And more sophisticated versions assume that it can be a function of human capital as well as other economic factors. So we have lots of theories, and we have a long story about technological change. And they discuss how technology develops and how technology improves. So a premise for these theories is that technology improves in either way, and once developed, nothing hinders its deployment. Okay, so basically technology improvement is improvement, meaning it is better technology. So everybody happy with that better technology. So nothing hinders its deployment. But counterexamples, another advanced core combined cycle generation, we say ACG. That's advanced technology. Intensive R&D has been made for many years, especially in Japan, and almost completed. But that technology has not been fully deployed and operational even before recent adverse circumstances against coal. Yeah, as you know, recently coal technology is kind of against, against recent circumstances. But even before that adverse situation, that technology has been almost completed, but that technology has not been fully deployed worldwide. PV technology has been constantly progressed, and high efficiency and low cost is attained, but its widespread use is not completed in this affirmative atmosphere across the world. So especially in Japan, PV is less than well, very few percent in the portfolio of the energy sources. The situation depends on the countries, of course. And energy efficiency in general, there are many high efficiency technology options available, but the market still keeps using old, less efficient options. It is a typical tendency. So good technology, we have a good technology available, but they have not been widely used. Why? So the point of an argument, technology for efficiency improvement or and cost reduction might be always welcome and thus must have been widely used. The reality is, however, not always the case. What is hindering force? So that's the question. If you are a business analyst or business strategist, you may say that well, it's a matter of the possible gap or leap between stages of R&D and implementation. They say, well, it is a so-called valley of death, or you may say devil river or Darwinian sea or something. So those are typical discussion in the business analyst or business strategist. They say basically these are only describing they say that's a typical tendency, but these are only describing observations, not giving full explanation of the mechanism. So nobody knows the mechanism. And economists employ their technical terms such as market imperfection to explain the mechanism. Okay, so of course, market is not imperfect, not perfect. So because of imperfection, so technology cannot, good technology can may not be used. So that's natural because market's imperfect. Okay, so that kind of explanation is very good. And that's kind of a typical textbook explanation. Adoption of technology for efficiency improvement or cost reduction can be hindered by the following factors, according to economics. Microeconomic theory, they say market imperfection, including market entry barrier, transaction cost, information asymmetry, negative externalities, and so on. So there's lots of list of items that constitute imperfection. And those things can explain why a good technology can be hindered. And the investment theory, tangible as well as intangible costs, including weighted average of cost of capital, so-called WACC, risks and uncertainty, payback time, liquidity of assets and capital, opportunity cost. Those things are typical explanation for the imperfect market. And so because it is the payback is long, so that technology will not be used, and even it is available, the liquidity of asset is the problem, and opportunity cost, you have opportunity cost or something. The risks or uncertainty, those are important things that they say. They point out these things as an explanation of the hinder against the good technology. And these theories imply that if the market is perfect, and if there's no extra cost needed for deployment after R&D, then nothing can hinder its adoption or widespread use. Okay, so if all these things are removed, especially if market is perfect, then and there's no extra cost, then good technology should be deployed worldwide. Widespread use is prevailing, should be prevailing.
Just a clarification question, maybe. So what do you call technology for efficiency improvement? You also put your renewables in that. I'm just referring to your previous examples.
Yeah.
So you would consider that PV
yeah.
and is an energy efficiency improvement.
Yeah. Yes. PV. Yeah. PV. But PV is an example. Just an example for the good technology, but not widely used. Yeah.
Okay, but I tend to consider that in general, energy efficiency is when you use less energy, not necessarily green or clean energy.
Right. Yeah, so this pattern is my focus basically. Yeah. Thank you very much for your clarification. And okay. So the aim of the study is the following. I address a research question. Even if the market is perfect, and even if there's no extra cost needed for deployment after R&D, is it still possible that adoption of technology for energy efficiency or efficiency improvement or cost reduction is hindered and face any obstacles? The question calls for the answer yes or no. Okay. The purpose of this study is to develop the simplest model for the explanation. It excludes any cost or market imperfection issue, and the assumptions are minimized, hoping it helps to provide implications for policy formulation. So like I underlined here, mine is the simplest model. And actually, I have once worked on complicated large-scale model like a computable general equilibrium model or something like that. But I think working on that kind of big large-scale model is kind of problematic in the sense that it contains lots of factors. So maybe we need to remove complicated things from the model, and I simply develop a very simple model for the explanation. And I recall a famous word from by the famous thinker Leonardo da Vinci. You know the Leonardo da Vinci. He says the simplicity is the highest form of sophistication, he said. So I like that word. So that's why I want to work on the simplest model here. Okay, so anyway, the model. Consider a single good market partial equilibrium situation. Example, electricity, gas, heat, insulator for building, and so on. And supply and demand functions are assumed as follows. Supply demand function is QD, which is a function of just price, and AP minus epsilon. And the supply function is QS, which is equals to BP. So this is a very simple model, both supply and demand. Epsilon, price elasticity of demand. And then the picture is showing the situation. You have a demand curve and you have a supply curve. This is a elementary economics textbook. Then equilibrium is easy to find in this cross point, which is P asterisk, that one. and Q asterisk dot one. Okay, so those are because the solution of the cross point, those are only functions of A, B, and epsilon. So those are functional parameters. So it is quite simple, and you can find a similar picture in introductory elementary level economics textbook. And consumer surplus, producer surplus, and social welfare, those are also elementary textbook of economics. Consumer surplus is defined like CS is equal to blah, 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 blah. And if you take a look at some elementary economics textbook, you will find that kind of picture. CS is the area of that one. And PS, producer surplus, is also this triangle and defined that way. And social welfare is the sum of these two things. W is equal to CS plus PS. So this is just elementary economics. And then again, equilibrium is the cross point of these two curves. Okay, so with this construction and modeling, efficiency improvement or cost reduction in the production of the good is described by the change of the slope of the marginal cost curve that is identical to supply curve. So this one is a supply curve, but this is also understood as a cost curve. And the slope, which is B, is understood as the marginal cost. So efficiency improvement can be interpreted as increase in B, meaning that you have a rotation of the or shift of the curve, like this way to this way. Okay. So yeah, okay. So if the efficiency improvement happens, this curve rotates, centering the origin to that way. Okay. So after the shift, meaning after the deployment of the new technology or energy efficiency efficiency improvement, it will give rise a change in consumer surplus and producer surplus and social welfare. So it is easy to see that this picture goes to this one, this triangle goes to this one, and then so you have new equilibrium here. Okay, so that's just easy economics. And then you can do a comparative statics. Efficiency improvement again is increase in B. B. Okay, and then you can calculate the small change of consumer surplus or welfare and producer surplus with respect to the change of B, which is efficiency improvement. So DCS over DB is equal to, so you can just the calculation, you can just do a calculation. Let me skip the detail of the calculation, but it is quite easy calculation. And you will find this equation. And it is to see that this is always positive for all B's. And also welfare is a sum of consumer surplus and the producer surplus. So you can add two derivatives, and then the desired calculation rate is written that way. And it is easy to see that this is positive again. but the question is that one. Producer surplus, the change in the PS with respect to B is written that way. Okay, so here we have epsilon minus 1. Then this means if epsilon is greater than the unity 1, then this part becomes positive. But if this is less than the unity, this part is negative. Okay, so yeah, so this is just same picture. So what does this mean? Increase in B definitely improves CS and W. So the replacement of the more efficient technology definitely benefits the consumer and the society as a whole. So good technology is also technology is always welcome, and they are welcomed by everybody. I mean, consumer and the society as a whole. However, the effect on producer surplus is ambiguous. It can be either increased or decreased. The divide is whether epsilon plus elasticity of demand is greater than the unity or not. So you can identify two possibilities. So it means it should be underlined that in the model, efficiency improvement or cost reduction technology requires no extra cost for the implementation. That is, free better technology is available to the producer. However, if so, we can say, why don't we adopt it? Why don't we adopt it? But the question is, who is we? Then when epsilon is greater than unity, producer surplus increases. Thus, all stakeholders will be happy with the better technology. As a result, nobody is willing to stop it. However, in contrast, when epsilon is less than unity, producer surplus decreases, even though the sum of CS and PS is increasing. As a result, the producer or the group of producers has no motivation for the adoption of the better technology. So producers are not happy with that new technology. So this means the divide between adopt or not adopt is entirely dependent on the price elasticity demand epsilon, which is a consumer side parameter, not on the side of the producer. So the divide is completely dependent on the consumer side, not producer side. It has nothing to do with the producer's current technology and the cost structure. On one hand, this seems a bit strange in that efficient technology will always benefit the consumers and society, but cannot be adopted due to the consumers themselves. But at the same time, or we can say on the other hand, the result seems quite reasonable because it seems that it should be matter of shares of benefit, since the total effect is always positive. Who can enjoy the great share is important. This leads to an idea of a necessity of governmental intervention that adjusts the shares by any public policy measures. So, policy implications. For a good for which price elasticity of demand epsilon is small, efficient improvement in production technology may not be autonomous. So they may not going to adopt that good technology. Notice that the typical goods of low demand elasticity commodities with high necessity for daily life. Electricity is a typical one. So in the, I think the electricity is a kind of a low demand elasticity, a price elasticity of demand, but still it is highly necessary for the daily life. So it is a typical case of the price elasticity of demand epsilon that is very small. And most energy services may also be example of this type. And apart from the energy field, another example outside the energy sector may include the telephone network, telephone technology development in this sector has been ongoing on especially methods of radio wave after digitalization, and the 5G is now available. And so 5G is a very, very high speed radio wave transmission method. But currently, many countries still using 4G or sometimes 3G. And shift is not so swift in the current situation compared to that of 4G from 3G. So from 3G to 4G was very quick. If you look at look back the past, it happened say within 5 years or so. But 5G, I don't think so. The shift is not so swift. Of course, there's many political reasons contained in that discussion, but apart from political reasons, still 5G is not swift transition from 4G. Why? Why? Maybe this is just a change of a speed up, and it may help consumers, but it may not help producers. So that will be another example of the that situation.
You have 5 minutes left.
Okay, thank you very much. Well, I'm closing. Well, that's for such necessary goods. Any governmental intervention may be needed for efficiency improvement to be promoted. And conclusion. Research question, even if the market is perfect and even if there's no extra cost needed for deployment for after R&D is completed, is it still possible that the adoption of technology for efficiency improvement or cost reduction is hindered or and face any obstacles? And the answer is yes, it is. Why? It is due to the nature of a necessary commodity goods, and improvement benefits the society and the consumer always, but may not suffice for the increase in the necessity, and may not benefit the producer. So there's no motivation for the producer. The promotion may not be autonomous. Thus, any policy measures will be needed for such cases. Okay, so that's it.
Thank you very much. So we have time for questions, in particular because I got the news that the next presenter is not going to be available. So thank you very much, Felipe, for investigating and letting me know about this third presenter. So we have some time for question to Akira Maeda. Yes, Sebastien.
Yeah,
thank you.
Thank you for the very thought-provoking finding presentation. I mean, it reminds me, I mean, this is, in essence, what you are modeling is the split incentive that we have in the energy efficiency debate, where I mean, is it the core of the result that the producer, there is some friction in the market and the producer is not able to reap all the benefit of energy efficiency? Does it boil down to this?
Say it again.
Sorry. Just big picture, it reminds me the split incentive problem where the landlord of an apartment building underinvests in energy efficiency because it's not able to reap all the benefit of energy efficiency because the tenants, the person living, let's say in the apartment, is paying for the energy.
Yeah, that kind of a similar situation. Yeah, I think. Yeah, because if you make a renovation for it and everybody's happy, but it may not give a benefit for the producer. So that's it. So it depends on the reason on the side of consumer, and it's very interesting in the sense that the reason is not on the side of producer, the reason is on the side of consumer. And your decision maker is basically the producer because they have that technology. And in my model, it has nothing to do with implementation cost because that just change your PB, not just change your B. And if you allow the change of B here, then it will bring some benefit to stakeholders, but not the project itself. So that's a discussion.
So I have a different idea. So, but maybe someone else in the floor wants to also react on that. Yes, thank you.
Yeah, thanks. My name is Lukas Kanzel from TU Wien, Technical University of Vienna. So thanks for this presentation, which was very interesting to me indeed. And I wondered, so which types of good exactly it is, let's say, applicable, or about which type of goods you have thought when doing this analysis. So I think it's quite clear, as you mentioned, electricity and gas, let's say energy carriers. But you mentioned in the beginning of the presentation also heat insulators as an example.
Okay.
And I wondered whether it's what you exactly, which type of good you exactly meant here, and whether to which extent these goods also show these characteristics of a low price elasticity. So these were just the thoughts that I had during when listening to your presentation. Could you maybe reflect a little bit on that? I hope it was clear.
So they're using the economics term. Low demand elasticity with high necessity is a typical example, I think. So you can think of many things, but in the context of energy, electricity is the best example, I think. But the renovation of a building, or so you can think of a very small market, or you can think of a very specific goods. But I'm not sure. I can not list up at this moment. But as long as this feature applies, low demand elasticity and with high necessity, maybe you can think of any types of goods.
Okay, thanks.
So maybe going back to the economic mechanisms, in fact, that was not quite clear to me why it was not a market failure, because what you showed to me was really a problem of monopoly, and the fact that, I mean, you are taking into account the fact that the price is going to react to the quantities, and to me it was just market failure. And another proof that it is market failure to me is that you say, well, we need policy intervention, which is another way to say that there is a market failure. So I think I did not really understand why. I mean, maybe you need to have a model, or maybe you presented a simplification with many producers. And so I don't really see why it is not a market failure here. For me, it is a monopoly issue, but...
Yeah, thank you very much. This is the picture. I mean, because this is a supply curve. It is actually the result of the sum of many suppliers. So you can think of the group of suppliers, or you can think of the single supplier, of course. But it is not a situation of monopoly, because you have the simple supply curve, and you have the demand curve, and you have the you have thinking of the just simple cross point, which is not a situation of monopoly. Yes, and if you have many numbers of suppliers here, you have the supply curve as a result of the of that situation. Sorry. So this is kind of also this is a partial equilibrium model, but this is a result of competitive market. Yes, and then the change from here to here is a situation like, say, suppose that if suppose that the increase increase of the increase of the value of B can happen autonomously. The increase in B is autonomous, suppose. Then are you happy with that? And if you are the producer, you just allow that change to happen or not? And if you are your producer and you will be happy, then you have no reason to stop it. But there will be one case where you want to stop that kind of change. So that's the logic.
Okay, I just wanted to mention another research that is also on this, that tries to explain why there are not so many adoption of renewables, which is within an optimal framework. It is done by Kevin Jenna, so from ex-Marseille School of Economics, and the story is on embodied technological progress, saying that all these infrastructures, that takes time to be renewed. So even if you have actually R&D happening, it takes time before there is implementation. So this is basically the...
Okay, thank you.
Okay, any other question from the floor?
This is Junko Gawa from IEJ. Okay, thank you very much, Maeda Sensei. And first of all, I have to say sorry that without notice, I joined this session, because just before this session, I found your name, so that I tried to join this session. And thank you very much for your presentation. That my comment, mine is just comment. And I understand that you try to explain the situation as simple as possible, so that I think it makes policymaker to understand what the situation is. And I think sometimes the policymaker cannot understand if it is very complicated. So your
Right. Yeah,
Mhm.
thank you. Thank you.
Your theory is very helpful for Japanese policymaker to understand. And also, I understand that in Japan, there are many various defined kind of policy and measures to the different kind of stakeholders. And I understand that's why we, because of the reason you explained today, that's why we have a lot of various measures in Japan. So yeah, thank you very much for clarifying the current situation in Japan. Thank you very much.
Thank you very much. Thank you. I appreciate it.
Thank you very much.
Thank you for your comments. Any other question from the floor? Again, we do have time because there is no third presenter.
Yeah, sorry, I have another question again. Just while thinking about your concept, and maybe it's a little, yeah, I'm not sure, but maybe it's a stupid question, but I wonder whether this technology uptake is, I mean, to my understanding, it's also the result of other markets. Or at least wouldn't the classical theory, the economic theory, reply to your analysis in the way that this technology uptake is also the result of other markets where for example, the market for PV panels, or the market for insulation material, or market for efficiency technologies. And the economic theory would argue that these markets work, and this leads then to this uptake, and doesn't need to consider and that's would be the reason why this, how I understood, split incentive between producer and consumer is maybe not so relevant then anymore for the good of electricity, as you explained it. What would you answer to this argument?
Yeah, I actually expect that kind of criticism. I mean, well, I know it is too simple. My mind is too simple. I know it, but it removes all things which typically discussed in the discussion of that kind of obstacles toward new technology deployment. So I simplified it, and I removed everything. And that's why I think the conclusion is very clear and very specific. And I think it can, that's why I think it can help, can be very helpful to policy makers. Like Jung said, the policy makers always prefer simple message. And my intention is basically to create a simple message toward policy debates. So that's I know we have lots of complicated and related issues in this context, and maybe you need to develop a more complicated model, like a computer generative model or something. And I have once worked on that kind of discussion and modeling. But this time, I tried to develop that kind of simplification. So
yeah, so thanks for that. And I have to say I really very much like this simplicity of the model, because it makes it very clear. So I just wanted to understand this aspect also from this point of view of yeah, very clear, very, yeah, as you say, simple model. Yeah, but yeah, thanks.
yeah, thank you very much. And at the same time, the interpretation is important, and we need to find how it fits the context of the policy discussion. It depends. So yeah, thank you very much for your comments.
Any other question? So anyway, I think we already had a very nice session, in particular due to the very early time in Europe for Europeans. I mean, it was a bit challenging for us, and I think we sort of managed to have something lively still. And it was very nice to have this opportunity to discuss with people from Japan during this conference. I mean, yeah. So thank you very much to all of you for attending this session. And I think I can close it now. And yeah, I hope you will enjoy the rest of the conference.